Good morning and hello everybody. Now we are going to study and complete changing Earth surface for grade 7. This week value for this week inshallah will be time investment and how can we benefit from the time and don't waste the time. It's okay? This is the week value. Now inshallah we are going to complete changing air surface and know the wind energy in changing air surface. What is the rule of wind energy in changing air surface? Okay. First, we are going to macro hill. Okay. Listen to me. How does wind change air surface? Okay, sediment transport wind. This wind make as a transport tool that make transportation from the sand, from the dust, from one place to another one. So it makes as a transport. Okay, type sediment transport. What's meant by it? Listen.
How does wind change Earth's surface? Sediment transport and wind investments. Erosion bundling can be the most important process that changes landforms. Wind.
So the first one is erosion. First is erosion. Erosion that wind make erosion for what? For the sand of mountains, for the clay of earth. This make erosion. After erosion, transportation. After erosion, transportation that transport the sand from one place to another. Okay, we are going to complete.
In weather rock, and it can erode and deposit sediment. The effects of wind vary, depending on the size of the sediment particles. Wind is capable of moving sand and finer sediment, as well as pieces of plants and other materials lying on the surface. A microscopic grain of sand can be moved easily and over long distances in a fairly short period of time. However, the movement of larger sediment pieces would take a longer amount of time and require more force.
Yeah, so is the meaning what? So is the wind. Sediment, transport, wind. Sediment what? Sediment, transport, wind. Okay? After that, after meaning the wind, so to complete the effect of what? Of wind. This is wind, okay? This what is a wind. Okay, this wind as stationary grains, rolling grains, bouncy grains, and dust in suspension. Okay, everyone. Okay, what happens to everyone? What is the rule of number one? Stationary grains. This is stationary. Stationary grains means what? Stationary grains mean what? Listen.
Three-dimensional thinking. Tap the buttons to show information about the relationship between grain size and wind erosion. Credit.
Okay, number one, stationary grains. Some object on the earth is stationary grains. Some object on the earth's surface are too heavy to be moved by wind. So it can't be moved by what? By wind. It's called stationary grains. After that, rolling grains. What? This is rolling. Rolling grains. What's meant by rolling grains? Rolling grains, if wind is strong enough, it can roll the grains of sand, silt, and other loose material on the ground. Can lose it. It's okay? It's according to rolling grains. Okay, bouncing grains. What's meant by bouncing grains? Bouncing grains, very strong wind can lift sand. Okay, very strong wind can lift sand grains and carry them short distance before dropping them. Before what? Before dropping them. Okay, dust. What about dust in suspension? Dust in suspension. Okay, dust in suspension Dust wind can pick up and carry fine material or light material such as dust. These particles can stay in the air, okay, for weeks and can be transported long distance. So dust suspension. So it's the effect of wind. If wind in transferring this material, how can transfer stationary grains, rolling grains, bouncing grains, and dust in suspension? It's okay. After that, how can wind change location? Okay, listen. How can wind
Collect evidence. How can one change the location of a sand dune or change the appearance of a rock? Record your evidence. See in the chart at the beginning of the lesson.
Okay, at the beginning of the lesson, how can we change it? Okay. Ice cube glaciers. What about the ice cube? Okay, how do ice change Earth's surface? Glaciers can also cause erosion and deposition. Erosion and deposition. A glacier, what's meant by glaciers? Okay, glacier, what's meant by it? A large mass of ice formed by snow accumulation on land that moves slowly across Earth's surface. It's called what? A glacier. So, it's a large mass of ice forms on the land and moves slowly across Earth's surface. Glaciers form on land in area where the amount of sunflower snow falls is greater than the amount of snow melt. Although glaciers appear to be motionless, they can move several centimeters or more each day. How does glaciers change Earth's surface? How? Okay, it means that the two pools there are an iced mountain. By increasing temperature, this iced mountain will be melted. When they melt, the water level will increase. When water level will increase, so it can cause drawing of coastal area and increasing in the water level. It's okay. So it's the effect of global warming. Global warming, that it's a phenomenon that make water level increases, okay, instantly in the coastal area. So when iced mountain melt, the water level will increase, okay, and make a drawing of coastal area. Okay, it means of glaciers. Okay. After that, this ice melt. What happens when this ice melt? What happens when ice melt? Yes, when ice melt, what happens? It will melt, changing to water and make increasing for water level, and the solid material of ice will disappear. After that, according to glacier shaping, okay, erosion by ice. Okay, listen to this.
How does ice change Earth's surface? Erosion by ice glaciers act as bulldozers, carving the land as they move. Glacial features are formed when rocks and grit frozen within the ice create grooves and scratches on underlying rocks. This is similar to the way sandpaper scratches wood. As a glacier flows down a mountain, it removes rocks and sediment next to its bottom and sides. This forms a smooth land surface underneath the ice.
Okay, so it's erosion by ice. Okay, what happens in erosion by ice? Okay, of this video that you are going to study it. Okay.
When it comes to a glacier shaping the landscape, this ability
This is ice mountain.
is a real secret.
What happens to ice mountain by melting?
Ice on its own is far too fragile to leave any mark on solid rock. It can only carve out a valley by picking up tools. The ice engulfs rocks and boulders as it moves down the mountainside. They pass through the ice and get dragged along in its underbelly. Together, they scrape and chip away at the rock beneath.
It's easy to imagine that this was once just one big mountain, and now all this space that we are in now is the result of the glacier taking its bites like this during thousands of years.
I like the way you talk about it as taking bites. It's almost like the rocks on the teeth of the glacier, and that's what it's using to grind away.
This is
It's been doing it
melting
up there,
fast.
making the valley bigger and wider.
If it was some other solid, if it was like steel or rock or some other solid, it would just sit there. It couldn't move, so it couldn't do this.
That's one of the secrets of the ice, that it's strong enough to carry these big rocks to work on the surface, but it's also soft enough to move.
Can you observe what happens?
Over the thousands of years that Nigot's plane has been advancing and retreating, it's been grinding down the rock like an enormous sheet of sandpaper. Gradually, it's turned boulders and bedrock into dust, so fine that when
This
it's washed
is
into
the
the
melting
lake,
of
it
ice
remains
by the
suspended
wind,
there,
by the
and it's
ice
the
temperature,
minerals in this
and
dust
changing into
that give the
water.
lake its colour.
So that piece of ice up there has done everything. It's shaped and smoothed these rocks here, and it's made these scrape marks and these teeth marks, and then over here, down there, the bigger boulders, and then the pebbles, and then the silt, and all the way through to the colour of the lake, even the shape of the valley. Everything about it, everything I see has been dictated and defined by the ice.
Observe. This is a video, okay? After that, this is the ice mountain by melting and changing in the Earth's surface, forming sea, ocean, and so on. Okay, it's your evidence. Okay, after that, what's meant by glacial debris? Glacial debris, okay? Listen.
How does ice change Earth's surface? Glacial debris. Glaciers carry an unsorted collection of large, commonly angular rocks to pulverize, fine-grained sediment. The sides of most glaciers contain especially abundant sediment because they receive loose materials from the slopes of hills and mountains that flank the glacier. This sediment is eroded as the ice pushes forward. When glaciers melt, the water produced by the melting ice does not flow fast enough to carry sediment. The sediment is deposited where the ice melts. Till is a mixture of various sizes of sediment deposited by a glacier. Deposits of till are poorly sorted.
This means of glacial debris, okay? As the temperature and wind make change in the Earth's surface, as melting of ice, as changing sand and dust from one place to another, it's called erosion. After erosion, transportation. The third statement or the third step is what is sedimentation. So if you observe what happens to this mountain, okay, this mountain contains of sediment layer, okay, layer after layer after layer. See, it's called the glacial debris, okay, as we see. Okay, glacier features. What's meant by this? This glacier features. Okay, this what's what horn. What's meant by horn? Horn is a sharp peak formed when several glaciers descend from the top of the same mountain. Okay, after that there is a kirk. Okay, kirk is a semicircular hollow that formed by glacial erosion. And this called what? As a glacier moves through valley, it curves away the mount, leaving behind a descending U-shaped valley. Okay, this is called what? Hanging valley. Hang valley forms when a smaller glacier at a higher elevation approaches a large valley carved by much larger glacier. A waterfall can form where the land drops off. Okay, this is the shape. Is the shape of what? Is the shape of this mountain. What happens to this, and what is the wind change from the shape of this? Okay. After that, how does ice change Earth surface again? Okay. This is that we studied. Okay, horn. Okay, as a U-shaped valley, hanging valley. Okay, Turkey. Okay, Eritrea. In the shape is a sharp ridge of the rock formed between two glaciers. Okay, this is a mountain and the valley. The image above would be different if a glacier had not passed through. After that, this slide is collect evidence how can a glacier change a mountain landscape. Okay, in D at the beginning of the lesson. Landscape change over time. Okay, read a scientific text. Earth's surface today is different from what it was in the past. And what it will be in the future. What it will be in the future. Okay? Landscape change over time. Landscape change what? Change over time. Okay? From place to another. The second paragraph underlines the meaning of uniformities. That's landscape change over time. Landscape change. Okay? Listen to this.
Close reading. Landscape change over time. In the 1700s, James Hutton, a naturalist and a farmer in Scotland, observed how the landscape on his farm gradually changed over the years. Hutton thought that the processes responsible for changing the landscape on his farm could also shape Earth's surface. He thought that erosion, caused by water and wind, could also wear down mountains. Because he realized that this would take a long time, Hutton proposed that Earth is much older than a...
This is a change of the landscape over the time that James Hutton observed. Okay? Hutton's idea eventually were included in a principle called what? Uniformitarianism.
2,000 years. Hutton's ideas eventually were included in a principle called uniformitarianism, uniformitarianism. The principle of uniformitarianism states that geologic processes that occur today are similar to those that have occurred in the past. According to this view, Earth's surface is constantly being reshaped in a steady, uniform manner.
But
Today, uniformitarianism is the basis for understanding Earth's past. But scientists also know that catastrophic events do sometimes occur. Huge volcanic eruptions and giant meteorite impacts can change Earth's surface very quickly. These catastrophic events punctuate Earth's slow, gradual story.
this is very important. Okay, this is an important paragraph. Okay, which is what? Which is huge volcanic eruption and guilt. Okay, huge volcanic eruption and meteorite impacts can change Earth's surface. Okay, so from the factors that make change for the Earth's surface is what? Is huge volcanic eruption. Okay, and meteorites that come from outer space. Okay, can change Earth's surface very quickly. This catastrophic events punctuate Earth's slow, gradual story. Okay, so these are from the factors that make change at the Earth's surface. Okay, complete. Okay, we read this. okay, of this. What we will observe in this, what we will observe in this image, okay, the volcanic eruption, the movement of wind and temperature that changes the Earth's surface, okay. Research the area where you live. How has this area changed over time? How might it change in the future? Use the link at least two valid and reliable sources to obtain data, okay, about your region. Your data can include the geologic history of the region, diagrams showing how the area changed over time, the time and spatial scales over which the area changed, and any other information you find interesting. Organize your findings and present them to your class using multimedia and visual displays to clarify your evidence. Okay? After that, how does ice change Earth's surface? As we studied before, the melting of ice is changing Earth's surface. Okay? This is the shape of mountains according to the wind. How might weathering, erosion, and deposition change the landscape over a short-term time, such as fractions of a second, week, and decades? Okay, how might the landscape appear in thousands or millions of years? Explains your reason. After that, this is the end of the lesson, okay, that we studied, okay, changing the Earth's surface. Okay, this is what studied, describe how water, wind, and ice can change Earth's surface through the process of weathering, erosion, and deposition. Okay, right in this weathering, what about weathering? What about erosion? Okay, what about deposition? Wind, ice, and this. It's okay, and now we finished the lessons that we studied, which is called changing Earth's surface. Okay, and we know the wind energy in changing the Earth's surface and what is its role. It's okay. Thanks for listening and goodbye.